Ladies and gentlemen, this is our third episode of the Masterclass Monday today, and I warmly welcome every one of you. My name is Kristen. I am the responsible person for marketing and communications here at Terra Systems. My colleague Manuel will clarify details on Cora and will make you understand why Cora is the perfect fit for this UI development framework and how to apply it best. But before we start, I want to give you further two hints regarding this today's webinar organization. If you have any questions, use the question tool and type your question in, and we'll be coming back to these in our short Q&A session after Manuel's presentation. And of course, as usual, the webinar will be recorded. And now it is Manuel's turn. You can start.
Yeah, thank you very much, Christine, for this very pleasant introduction. Good morning, good afternoon, good evening to all our attendees worldwide. It's really a pleasure to have you here in this third episode of the Masterclass Monday series, covering now the very special topic, the own programming language, Cora inside Embedded Wizard. So, what will be the topics for today? First of all, I'd like to give you the background information why we have chosen to implement and to support an own programming language. That means I also give you a short overview about the key features inside the Embedded Wizard Studio at the end. I also like to give you a brief overview about the object-oriented programming approach that can then be done with Cora. I also give you an introduction and then some small overview and short overview about the I call it key players inside GUI development, which are the property slots and observers. And finally, I give you some further hints and tricks and best practices when dealing with our programming language. So, why have we chosen to implement an own programming language? Honestly speaking, when I joined the company and when I get familiar with Embedded Wizard the very first time, I really thought, why have they added a new programming language? There is plenty of programming languages out there. So there is C, C++, Python, JavaScript, whatsoever. But I really identified very, very, very fast that there's no general purpose programming language out there which is dedicated to GUI development. So Cora is a programming language which is dedicated to GUI development, as for example it supports built-in data types to deal very easily with lines, rectangles, colors, languages in terms of the language of the GUI, etc. Furthermore, we have also added the support to implement or to follow design patterns that are very common in GUI development very easily. So it's very easy to implement an architecture led by the model view controller paradigm, by model view presenter, model view model, etc., which are very well known and very common in terms of GUI development. Something which is also important when dealing with more complex GUI projects is to have the support of a proper object-oriented programming. And this is something which is the base inside the Embedded Wizard. However, Embedded Wizard's Cora is a very safe and a very strict programming language. That means you cannot do any pointer arithmetics, for example. You do not access any initialized data. However, taking that into account, it's also important to know that accessing freed objects is also not possible due to the built-in garbage collector. Nevertheless, it's also very inspired by very common modern programming languages, as you see C#, C++, Java, JavaScript. Cora itself is not a domain-specific language. It is a Turing-complete language. That means you can implement your own algorithms, your own methods. You can do everything, so all problems can be solved. Something which is also important from our point of view, just remember, we're following the source code generating approach. And at the end, Cora is then used as the base and is then transferred, translated, compiled to another programming language. And as of now, we are supporting ANSI C and JavaScript. And something that is also important from our point of view is that it's not cryptic at the end. So you should really identify what is generated so that you understand that you can properly debug that on the hardware. Hence, we really ensured that the output of the generated sources is human or is very human readable. This session will cover only the most important things of the language. We have a full documentation and a full reference manual made public on our knowledge base, so please excuse if I cannot or if I will not dive every aspect and explore every aspect of the programming language, because otherwise we could spend not only an hour or a couple of minutes, we could spend then a couple of days to cover really everything. So please have a look at the reference manual. It's very sophisticated, it explains every aspect and every type of the programming language, and if something is now missing from the next couple of minutes while I'm doing the presentation. So now let's get started and jump into the Embedded Studio, where I can now show you further aspects on how to deal with the programming. Therefore, I'm just creating now a new project, and say it's an empty project, and the name is of this project Masterclass episode 03, and let's create a new project. Now, when starting this project, you already see the first thing that you see is already based on Cora. For example, on the left side, when the gallery is open, then you see that the first entry inside the gallery is dedicated to Cora, so to the project members of the programming language. In fact, to add new stuff into the UI project implies to do a drag and drop from the gallery now into the composer. That means you can now add a new unit, for example. A unit is something like a container, like a package, like a namespace where you can group different other items and different other members inside your project. This helps you to find a proper architecture. This helps you to structure your UI project. Every UI project, when you create a new one, already has dedicated units. Those units belong to the so-called Mosaic framework, which is the base to deal with the classical UI development purposes. So drawing a rectangle, adding an effect, etc. These are all implemented inside the Mosaic framework, inside your project, and this is implemented already with Cora. So by drag and dropping different units, you have then a possibility to structure your project. The very first one is the application unit, and this one has already a new class. Now, what you can also do now from the gallery is to drag and drop new classes there. Something which is important to know is that when starting the prototyper can only be done on several dedicated classes. For example, this root class. You can now press the play button and the prototyper gets started, which shows now in this case a very empty application. However, going back to the application, when you have added the new class and you double click on that, which opens the implementation of and definition of the class, does not have any view to represent. Of course, you could now add a variable or a property or a method, something like that, inside this class. However, something important to know that the prototyper itself can only start the simulation of a class which is viewable. So in that case, when I would now press the play button, not for the application, sorry, the play button which says start the prototyper with a currently opened view, then it says that it cannot prototype this class because this class is not derived from the viewable core group class. Core group, this is the Mosaic implementation of a viewable element. That means we need to create some kind of testbed later on in order to show you something. So what I now added inside this unit, for example, is that I drag and drop now this class. However, there are other things that can be drag and drop now into a unit. For example, a constant. A constant can be, by selecting that here on the right side, you see that, can be, for example, a string. However, it could also be different kind of other types. As said before, inside Embedded Wizard we added data types which are dedicated for GUI development, and therefore you see, for example, that there's also a data type called point, that there is a data type called language, that there is a data type color, and there's a data type called rect, for example. And these are special data types which can be used when dealing with the proper implementation of the GUI application. By selecting that, so this constant here, so for example, let's give it a name, which is my string const, for example, and say, okay, it's not of type point, it's of type string, and you can also add a dedicated value, e.g. hello world, and then you have stored this string value inside that constant string, my string const. So going now into the class, and if you would now like to add also this constant here, that you see, okay, it's not possible. So inside Cora, you can only add different kind of members, so-called project members, into not to everywhere. So you cannot add the constant there, or you cannot add a unit into a class. And you can also not add a unit into a unit. So nested units, for example, is not supported. So you really need to take care about what element can be added to another thing. And this is something that is important to know, and so that you get not frustrated. There are certain limitations, like what I said, that you cannot do any nested grouping of units inside a unit. Just one thing to keep in mind. Something that I mentioned before, Cora itself is an object-oriented programming language. Object-oriented means that you can, for example, also derive from superclasses or from parent classes. In that way, when I've now added this constant, the class from the gallery now into the composer, it's just an empty class. Therefore, it's really empty. You see that also inside the inspector, that there's just this class. I have then added a variable, I have added a property with dedicated onSet and onGet property methods, and a very simple method. So for the object-oriented approach, where now to define from which class, for example, a class should be derived from. And that way, when I'm now inside this unit application and I have selected this class here, then you see the attribute superclass. And superclass, this is now something where I say, okay, please derive yourself from the core group class, which gives me the possibility now to prototype this class. So going back now into the class implementation there, then you see that, for example, that there's also now this small rectangle appearing, which is now the border of the bounds, which makes this view visible. So due to the fact that I have now made this class derived from core group, that implies that other parameters, so like variables and properties, are now derived from core group class. And you see there are quite a couple of elements added. In fact, there are 93 elements already defined inside core group or inside any other derived classes. And if you want to see the whole path of where dedicated classes are derived from, then you can also switch now to the browser view, and let's search for our new class, the class, which also indicates now, okay, where is now this the class derived from. As said before, I defined the superclass core group, and core group itself is already derived from correct view, whereas the correct view is already derived from core view. And this indicates about all the dedicated inheritances of my final the class application. So one benefit that gives me now the possibility to derive when I was derived, that I can now also prototype this application. So this is now working compared to the previously try where the class was not derived from the core group class. So let's have now a more closer look about the standard elements to be added with a programming language. So for example, this variable there, And you see that a variable is already indicated by this brick, which says, okay, it's a var, so var, which says it's a variable of type integer 32. Changing now the data type of that integer 32 type is very easy. Just select now this brick there and change that from integer 32 to, for example, a string, or to a uint32 data type, for example. And that's a possibility to change different data types. The same applies now to a property. A property, what is the specialty of a property? I'd like to mention that later on. And the question is, how would you now change the data types or the return values and the arguments of a method, for example? By selecting that and double-clicking that, it opens now the implementation of the method inside the editor. Changing now the return values and the given arguments is very easy. Just double click now on the first line here where the definition of the class is mentioned and shown, and by double clicking as well the first line where you can say, okay, let's return a string, and let's take not an integer as an argument, also let's take a string, sorry for that, a string as a given argument. Next to the different kind of elements, so variables, properties, methods, units, classes, constants, return values of methods or arguments, etc., there are also statements available in Cora that can be used for the programming. Of course, there is an if statement, there is the while statement, there is the for loop that can be used. But next to those there are also built-in functions, like not the print or printf. In our case, it would be the trace, and the trace would say, okay, I have given the argument called a1, and that would now print out the given string into this debug window of the log window. Furthermore, there are also, for example, built-in variables available. So let's trace the currently used language, which is in that way here the default language, which can then be used also for your further programming. So for example, think about to change something depending on the currently set language identifier. Next to those built-in variables, there are also built-in functionalities or functions available, so like a math sinus function. And we also have built-in, built-in macros available, like for example the currently set and currently the question about if I'm running now inside a prototyper or inside the composer, and therefore you can ask that. And those macros are identified by the $sign. And let's take, for example, if I'm currently using the prototyper, which prints out now true or false, which is now a Boolean value in that case. Please keep in mind that this method requires to return a string, because we defined that the return value should be a string. Hence, we just say, okay, return now, for example, my arg1. Even if I have now defined this method, so now I would like to test that. So how to do that? Think about that, what I mentioned before. You can only core group classes can be simulated by the prototyper by pressing the play button here. When I now press the play button, it only starts, but it's empty and nothing is happening. However, this class now is derived from core group, and this core group also comes with a constructor, or every class can have a constructor, and that constructor is the init method. So how to derive now this init function or the constructor in order to invoke now our predefined method, for example. And therefore, I'm just now selecting that and say, okay, override class member, which makes the proper derivation from my init method. You see that is derived, that the element, so this init method is, or the text color is set in gray scale color, whereas my new method that I have added before is in black color. Double clicking on that opens now the implementation of the init function, and what I'm now say, okay, just method call and invoke that with a given argument by init, for example. So very easy. So now when I now press the play button, this application gets simulated, the init gets invoked, the init invokes now the method, and the method is now doing what we have programmed before. It says, okay, give an argument by init, the language is printed out to the log window, which is now the default. The default element, we have trace of the math sinus function, which is of course 0, and I'm running inside the prototyper, hence I'm getting back and returning just a given argument. Something also important with the trace, but double clicking on that opens now of that element, points the cursor now where this happens. This is also very useful when, for example, you find some error messages or these traces, and by double clicking on that you can jump directly where this trace method is printed out. So we are already strived a little bit the concepts of object-oriented programming. Now, how does this object-oriented programming affect the GUI development? Therefore, I just like to make a very short example. An example that is very common is to implement some kind of a button, and therefore I'm just defining now this class, and this class should be my button. And remember, we should derive from core group, hence I'm making the superclass set to core group, double clicking on that, which opens now my button implementation. My button should be a little bit more bigger, so that means the bounds itself should contain this size, which is now 210 by 50 pixels, and it should be a very simple button. That means it should be or should have some background, and the background has some red color. It should also have some text, so just positioning that a little more, zooming in, and use another font like this. I think font medium should be, or make it a little bit more bigger, so font large is okay. So there's just text and the rectangle. So before just doing some core object-oriented methods on that, I like first to define that button. A button, or how to do an interfacing to this dedicated implementation, would be now to add a so-called property. A property is a better variable, I would say. Better variable means that in fact it's still a variable, so it holds the information, but it comes with onset and onGet property methods. Onset and onGet property methods means that every time you are writing to this property, the onset property method gets invoked, and every time you're reading from that property, the onGet property method gets invoked as well. So, however, it should not be the property integer 32, it should be the property of type string. It should have an empty string, and let's just zoom it out a little bit, and it should be of name caption, in order to define this button text here, what should be made visible. So this is now the caption. So remember, every time you're writing to this caption, the onset property method gets invoked. In that case, the onset caption property method. Double clicking on that opens the implementation. In fact, this onset property methods and onGet property methods are somehow a little bit special, because they come also with further statements. In that way, we have, for example, the statement pure caption equals value, which would be then the second built-in variable that you see now. Those are only available inside the onGet and the onset property methods. And what do they now work from? Every time you're writing now to this property, the given value is given in that instant built-in variable called value. So that's the current value. This property gets set when assigning a proper value to that. However, to store that and to overrule the possibility to invoke this onSet method is to define this caption with the pure statement before. That means when writing to this pure caption property, this onSet method gets not invoked and the entire value is assigned instantly. And the same applies now when reading. So when reading now from the caption, then it just returns the pure value of the caption. Otherwise, it would just be some recursive invokement, and it would get fed back with every next iteration. So please keep that in mind. So every time now I'm writing now to this caption property, I'd like to update this text as well, and therefore I can just say okay for this text, and this text has also a property, which is the so-called property string, and that string property is simply then assigned with a new and given value. If you're not 100% sure, you can of course say, okay, what is my currently given value, for example. This is of course possible. Prototyping that, you see it's just text. Debug is nothing out there because we are not assigning that property outside. So how can now then this be used? For example, going back now to my own class, which has now these built-in functionalities and these previously added stuff, and just make it a little more bigger. And therefore we are just now adding our new implemented browser button. The implemented button. So we are now searching for our button class that has been implemented. Drag and drop that element makes now an instance of that button. That button, when selecting, appears now inside the inspector with dedicated further properties. Now think about what we've done before. The button inherits the behavior and the data from the core group, and that's the reason why you find also additional properties there. So there's the property opacity, which defines the alpha value, for example. It has the property bounds, which defines where this button should be positioned inside the canvas. It is said visible, true or false, and these are all, or these belong to the core group implementation. However, a new property that has been added is the caption property. And remember, we said this is an empty string, and what we are now doing, this is my button, and define that. So every time I'm now assigning now this value to this property of my button, of that instance of that button class, it is assigned entirely now to the text element that is there. And remember, we also added the proper trace, so double clicking on that says okay, tracing the given button back again. Something also important, so double clicking on the implementation, a property itself does not need to have this onSet and onGet method. So for example, when I'm not reading that onGet method and do not have any customized implementation, you can also just say okay, right click, delete, or press the delete key on your keyboard, and it gets rid of, because it's no custom implementation, and then the default behavior is then used, which simply returns the given property automatically. Okay, back again to the topic. We said object-oriented programming. Now we have a very simple button that still has no event handler built in, so it does not react on touch events or key events. Another story, but it already has the possibility to define the proper caption. Now inside your GUI project, for example, you would also have now different kind of buttons. Think about a button with some further decorators, like a rectangle, like a not a rectangle, like a border, or like an icon which indicates some other type of button. What you could now do is just now going back to the application, and there we have the button, and say okay, let's make a copy and just do a paste. So that means we have a new button, but in fact it's then just a copy of that with the caption properties already there. which really doesn't make much sense to have an implementation. And this is something which I really encourage you not to do inside your GUI project. Just think about how to make things common that can be made common. So the question is, split those complex things into more independent, into more reusable objects that contain certain properties. So it doesn't make much sense now to make a copy of a copy of a copy of a copy. Yeah, and when you just think, okay, this should not be the caption property anymore, it should be just a text property, something like that, or a new property, I don't know, then you would have to adapt that through all of your copied button implementation. So let's remove that, selecting that and delete. So what we are now doing is just copy that as well, but we are now doing a derived paste. So that means this class itself, as you see, is now derived from the superclass application button. And as said before, we would like to implement some button with a border, for example, and just renaming that. You see the bricks that are before, so switching now the view to the application button, those from the bounds and the caption and the onset caption method, these disappear inside the implementation of this button border, because we are now following a further derivement of this application button, and they are now all gray like the other properties and variables that we have inside the Mosaic class. However, you can now change the interface. That means you can just add, for example, a new view, which should be a new border, and drag and drop that element into this border with some color out there. And of course, the color should be changed of that border. Let's, for example, make it also a little bit more wider, so not 1 pixel, let's say 3 pixels wide. And it should come with a new property in order to be controllable through the where this class is initiated. And therefore I'm just say, okay, not color, border color, let's take it that way. And it doesn't come with a type of integer, it should come with a type of color, and defaulting not a solid shell. So we do not read that, so remove that. We have here the onset border color onset property method, and what we are now doing is just say, okay, by the way, when I'm editing, I now have pressed the control space on my keyboard, which opens the assistant and gives me further possibilities to add, and therefore I have now my border instance there, so which is now the white border, and this one comes with a color, and this one is now assigned by the given value when this onset border color is invoked. So going back now to my implementation, just make now a drag and drop of my border color, and what you now can do is change with a new color property. Where is it? Border color property, a new value. For example, it should be more a gray value, and the effect comes into place automatically. Of course, we can now change also the caption, which says, okay, this is a border button, for example, and here we go. So very, very easy. Now think about a third one, just to complete that. So in fact, you would have now not a button with a border, you would have a button with an icon, and now I can copy that and do a very simple paste, because it is already defined to be derived from this superclass of my common button, and now just renaming that to my icon button, for example, double clicking on that. So this is not the color, this is not the border, it's just not the something that I mentioned implemented in the button border before. And what I'm now doing is inside the views add a new image and say, okay, this is a new image there, and like before can just add a new property which says, okay, this is my a frame number of the given element. Selecting that image here, can use different other images, and for example I'm now using some pre set icons there. For example, I think this one should work, symbol icon medium, which has different other frame numbers there, and like before, removing that, double clicking on that, and can assign that the new given frame number of my given value when it's set outside. So going back now to my test bed and adding there a new text button, something like that, and say okay, this is now my icon button, for example, and has new frame numbers like 2 or 3 or 4 or 5, I don't know, something like that. So next to these object-oriented programming features that Cora enables, I'd like also now to have an eye, or to put an eye onto the 3 key players that are very essential when it comes to the creation of user interfaces. So the first thing that you already saw are the properties. So with the properties, which is somewhat the better variable that you saw inside these buttons there, where you have dedicated added new button, new elements, new properties like the caption property, for example, or the frame number property of that other button there. So it's there to write to new variables with the customizable onSet and onGet methods, and which are then what can be seen as a typical interface to an object when it is instantiated. Some additional things that are essential to know is how you can also add with the properties, or when you're dealing with properties, in terms of how to reference to those. In fact, just opening now the init method that I'm having here, and we also have now this very simple int32 property. In fact, when we now would call property equals 42, I don't know, property, and just go to the onSet and say okay, let's for example just simple trace the value, or the given value. Then starting again, then you would see okay, it is properly set, and that's it. Another thing is to work with properties is the usage of property references, and that means when you want to now connect, for example, different kind of properties, now a common pattern that these property references can be added with the so-called dashes, which is now a dereference of a property. So that means it's now the dereferencing of the property, whereas the reference of a property is used with a dash before the property name. And this is now essential when it comes into the next part, which is the observer and the dedicated slot methods. So just keep that in mind. We will use that later on when we are now attaching different kind of observer to slot methods, etc. However, now I need to explain what a slot method is. Therefore, I'm going back to my templates gallery and drag and drop a dedicated slot method now into my canvas. As you see, a slot method, or it's also called a slot method, is a very simplified method with no return values, no arguments. Just double clicking on that opens the editor, and as you see, it does not have any return value, it doesn't give any return value. However, it only has per default a dedicated variable or built-in variable, which is the sender variable, and by just giving a trace on the sender element, on the sender variable, would now trace who is, for example, now emitting a dedicated signal, or who is now invoking this slot method. I just said it. Invoking a slot method also implies that a dedicated signal is sent to that dedicated slot method. Therefore, just now back in the init method, where I would now say, okay, let's emit a signal to my slot, And what happens when I now press the play button, it just say, okay, trace at some number, which is the reference number of this object of this class where I'm now actually in. So with that, you can very simply signal and sending a signal to the slot method, which gets then invoked. By just hitting now signal or typing signal, this implies that the slot method gets called synchronously instantly. If you want now to decouple that a little bit, or not a little bit, if you want to decouple that and put some kind of asynchronity inside the UI, then you would say, okay, not post method, sorry, you would say post signal to the dedicated slot. And with that post signal, the processing of the referenced slot method gets decoupled from the current process stack. So that means a signal is emitted into a queue, and then it gets processed with the next loop of the embedded wizard processing function, but before the display update happens. If you want to achieve that the invocation of the slot method gets done after the next frame, that means after the next main loop has been processed, you would not post signal a slot method, you would put an idle signal there. Idle signal then invokes this slot method after the next frame has been happened. Now we have these slot methods, we have properties, we have property references, and with that you can now connect both together. And connecting both together would mean that, for example, you could now say, okay, I'd like to attach an observer. Attach, and the app server is an observer with a dedicated slot. In that case, it is our slot with a reference to my given int32 property. So what's now happening? Just remove that for now, and remove that as well, and just commenting out because it's not needed right now. So with that line of code, I'm saying, okay, please listen now on any changes of that property. And it's not given as a value, it's given by a reference. And in case that anyone says, okay, now you need to receive a dedicated notification, then my registered slot method is then invoked. And this is something like you would that you usually know from defining a callback function and assigning a callback function now to a dedicated variable that can be called later on. So this is the technique behind. So having this kind of attach observer, you can of course then later on say, okay, let's do a detach observer by this slot method, and or just going there, detach observer with my slot with my dash property, and that would then imply that the currently made connection, so who is now listening on that property reference, is now then decoupled again. With that technique, you can dynamically listen on changes to different property references and gets invoked then later on. The question is, how is this then now happening? For example, when I'm now writing this property, when does this slot method gets then invoked? And therefore there's the third argument required, which is the so-called notify observers with my property reference expression. So in that way I have all the three essential statements mentioned. So how does this now work together? So usually when you are now assigning a value to a property, so in this onset method, you would say, okay, let's go ahead and don't detach, so just say for the attaching, in this onset property, let's notify all my observers that are listening on changes of my property. So what I'm now doing inside my init method, I'm saying, okay, first of all I'm attaching, and then later on I have my property, and it gives me a new number 4711, And I'd like now my slot method to say, okay, this is now being invoked, but I'm now used to react on these different kind of changes. I can say, okay, trace my new value set to the property with my current property value. Every time I'm now notifying any observer, and of course you can add now multiple observers that are listening on changes of this property reference. Every time I'm now emitting this call, so notify observer, every time a post signal is invoked. So what's happening when I now press the play button? Just clear the log right now and press again the play button. Then you say, okay, 4711, this comes from this trace there, where the onSetThis method is called. Then the notify observer is then happening, and with the now dedicated, say, okay, dedicated new value has been set. The new value has been set to this property with the current value on that. If that was now too fast, and if you do not see the proper things inside how to connect that, I really like to refer now to the knowledge base, which gives you much more details on this pattern and with this notification and observer pattern that is available. However, you can not only listen on changes of the property, as for example you see when I'm now adding this attach observer statement, then the assistant say, okay, you can register any slot method to the null object with a dedicated ID. This makes sense, for example, for global notifications of dedicated IDs, where an ID could also be an enumeration, for example. And or you can also listen on changes on any objects, or what we are now using on property references. And this is something that you already perhaps know when using our widgets. We have there the widgets with a dedicated push button there, for example. Oh, sorry, there's this one missing. Reloading the class. And that one has now, as you see, a dedicated new element, which is the on enter, for example, or the on activate, which is a property with a type slot. So you can assign a dedicated slot, which is then invoked every time this push button is pressed. Then assign slot methods gets notified through the previously registering at this on activate slot property, for example. Last but not least, I'd like also to mention inside the Cora stuff, because we've now spoken a lot about the classes and instances of classes, so objects, are there also the possibility to have some global objects, because everything is now usually invoked through the root application. And yes, there is also the possibility to have this kind of global instances, and this is the so-called auto object that we have. So for example, we have here this class, and what I now can do is just make a copy and make a derived paste, and then you see not a derived, sorry, an instance paste, so that's on, and then you see that this one is now set as the dedicated auto object. So it's an initialized object about the class. However, something important, it's not there for all the time. So it's not available all the time through the entire runtime of the GUI. As the name auto object already implies, it's get initiated automatically every time you are accessing that. And this is something where you have to be kept in mind when you put this kind of a global object into the system and you store data inside that if there is no reference to that dedicated auto object, then the garbage collector simply says, okay, there's no reference, just removing that from my memory, so it's deleting, and hence all the saved data, for example, are then lost. So please keep in mind to keep a reference of those dedicated auto-initiated auto objects if you want to keep the data not being removed after the garbage collector has been finished. How to achieve that? Usually what I'm doing is inside my root object, I'm just simply adding a very simple variable where I say, okay, this is now my my global class, something like that, of type not integer 32. I have here my class, the class, and the default value belongs simply to the class 1, which is now the name of that auto object. Let's say this is my global object, something like that. And then of course Embedded Wizard takes care about with that immediately. And with that you can ensure that you already have a reference to this auto object, and hence it will not be removed from the garbage collector because now reference is there. But please keep in mind, if you would now have too many auto objects and you do not use them, then of course it will have a not so good impact on your memory management at the end. So this is something for now. It was quite a lot of stuff and not so easy stuff to transfer. So please excuse if something was not so precise or something not so conscious in terms of how to tell you what the pros and cons are. Nevertheless, please have a look at our knowledge base for all the Cora aspects, and I'm now very happy to hear now you with your proper questions, so that I can answer you them right now. So thank you very much for that one. And yeah, Christine, what questions are now popping up or have been popping up during my not so short presentation right now?
Thank you, Manuel. So now let's come to the question and answers section. I pick up this one. Is it possible in Embedded Wizard to pass a pointer to a function and modify the value as you would do it in C, C++?
Yeah, so in fact, so just jumping back to Embedded Wizard, this is something that we already had here with a property where we are using the property references when I'm, for example, here using the attach observer method. So in that way, we're just using the reference of a property. So this is something that you could also do inside a method declaration. So you would then just say this is a property reference, and then you get that, or reference to a property, and with dereferencing you could then change the value without adding an additional overhead for that. Another approach would be to define a dedicated class. So for example, I can just drag and drop that and say, okay, this is a data class, for example, where you can add certain variables, for example, so variable 1, 2, etc., and then just pass an object of this data class to the method, where you can then add further things. So for example, here what we are now doing with the object. So for example, here var application data class data equals new. By the way, new is also a statement in order to initiate objects during runtime. So we have here the data class data, and then you can say, okay, data variable equals, I don't know, 765, etc., and pass then that data object to this method by the given data. Of course, I would now need to adapt the method there, but this would be then the second option that you have.
Thank you. Okay, here's another question. Does Cora provide a constructor and a deconstructor?
So you would mean a destructor? Yes, of course. So what you see, the constructor is used when initiating a object, what we are already doing here with the init. However, another object or possibility would be to define now a destructor. In that way, just adding a new method and call by convention, which would mean where an init is should also be a done, and that done is the destructor. However, please keep in mind to remove any return value or any argument, and just say return, which is then the destructor that gets then called as soon as the garbage collector would remove that. So if there are any further references, and this at the end would then be your destructor, where you can do further things, for example.
Let's pick out this one. Actually, we are in the lucky position again that there are loads of questions coming in. I'm afraid we cannot cover all of them, so we must come back to you via email in order to answer them individually. So, but I pick up this one as a third question. Why does Embedded Wizard not support a delete operator?
Yeah, so this is quite easy to answer. The entire memory management, and so the built-in memory management within Embedded Wizard, is controlled by the just mentioned garbage collector. So it ensures that the memory is released when it is not used anymore, and that means that you never need to worry about that, which is a very common concept in other programming languages like Java, JavaScript, C#, for example. And as soon as there are no further references to a dedicated object, it is hence unreachable and can be freed by the garbage collector. And a very big advantage in that is that you cannot access any object again which is already freed, so you cannot free any objects twice. So this is a big benefit, and also one additional benefit and advantage for our programming language, what I mentioned earlier, to make it very safe and very strict programming language. So as Christina already said, I think that's fine for now. So quite a lot of stuff. I really like to thank you very much for your time for this not so easy topic today. I really encourage you to have a look at the knowledge base, and for the proper Cora reference manual where further tips and tricks and things are mentioned. I really wanted to give you a brief overview about certain aspects, and for that I'd like to thank you for your time and hope to see you soon, latest next week, next Wednesday, next Monday, so on Masterclass Monday with the next episode. Thank you very much, take care, stay healthy, and goodbye.
Thank you very much, Manuel. Yeah, we're coming to an end now. After we close this webinar, you are maybe already used to it, that there will be popping up a short poll. If there are things you want to share with us, some information about your project, questions which go deeper into your project, whatever it is, whatever is on your mind, you can feel free to share this with us after this webinar closes. So I want to thank you again for attending, and I wish you a perfect day. Bye.